Hi, pre-calculus students. Welcome to section 4.7, inverse trig functions. So here we will be given values of trig functions, and we will be finding the angle where that value occurs. It's not like we did before in section 4.4, where they asked for any angles on the unit circle where these trig values occurred. These are inverse trig functions, meaning that for only one trig value, there is only one angle value associated with it. And so just grabbing my calculator here. Just wanted to show again, we are working with above the sine, cosine, and tangent buttons. We are working with inverse tangent, inverse cosine, and inverse sine. So let's take a look. If you have been given a value for sine and they are asking for the angle where that occurs as a function, that is called inverse sine or arc sine. Arc sine I prefer because it reminds me of I am finding the angle where sine is. Inverse sine, inverse cosine, and inverse tangent have the -1 on it like I showed on your calculator. However, the button next to those inverse trig functions also has a -1 on it, and it is in fact a reciprocal. So take a look here. Inverse sine, inverse cosine, inverse tangent, and here is x to the -1, which is 1 over x. These are not reciprocal functions. These are functions where when you have been given the trig value, it gives you the angle. We did not have these when I was young. We only had these, which I think makes more sense, so I use them more often. If you have been given a value of sine and they want the angle where that sine value occurs, you are allowed to answer in the first and fourth quadrant between a -π/2 and a π/2. You are not allowed to answer in the second or third quadrant. Notice sine is positive in the first, negative in the fourth, and so you have everything you need. So arc sine, its output is, its range is from -90 to 90 degrees, or -π/2 to π/2. Let's jump to arc tangent, inverse tangent and arctan. If you have been given a value of tangent and you want the theta, you are again allowed to answer in the first or fourth quadrant, okay? Because tangent is positive in the first, negative in the fourth, you have everything you need. And you do have to rotate negative into the fourth quadrant. You do not rotate around the circle into the fourth quadrant. You are only allowed to answer between -90 and 90. Cosine, inverse cosine or arc cosine of x, where you're looking for theta, you were allowed to answer between 0 and 180 or 0 and pi, right here in the first and second quadrant. Notice cosine is positive in the first quadrant, negative in the second, and you have everything you need. Okay, let's try some examples. Number 14, they are asking for arctangent of a square root of 3. I have memorized, or it is on my left hand when I flip it over, that if I put the π/3 finger in, the tangent is the square root of 3 over the square root of 1, which is the square root of 3. So that is, that angle occurs at π/3 in the first quadrant. Is my theta. Where inverse sine of a negative square root of 2 over 2, notice with sine, I'm allowed to answer in the first quadrant or the fourth. Sine is negative, I must be in the fourth. And I know that sine is the square root of 2 over 2 at π/4, right? So my angle must be a negative π/4. The angle is π/4 because I know that's where sine has a value of a square root of 2 over 2. I know I've rotated a -1/4 into the fourth quadrant because my value is negative, and that is an acceptable answer that I am allowed to output. On number 44, the question is they ask you to write a trig function, an inverse trig function, in terms of the picture that you see. Okay, so What I first do is I'm really good at writing a trig function. I see that I have the adjacent side and the hypotenuse here, right? And that would be cosine. So cosine of theta is x over 4. But they want this written as an inverse trig function. That means that arc cosine. Oh, let's try that again. There we go. I see an adjacent side and a hypotenuse, and it would be adjacent over hypotenuse. There we go. That's better, right? Adjacent over hypotenuse, right? And that would be arc cosine of 4 over x then would give me the angle when I write it inversely. Just so you know, not a huge fan of having an x in the denominator. So what else could I do? I could also say that secant of theta is x over 4, right? Hypotenuse over adjacent. And then I could say that arc secant of x over 4 equals theta. Right? Either one of those is perfectly acceptable. Okay, let's erase, and we are going to evaluate the next two problems. Here we go. Tangent of arctangent of 1. And arc cosine of cosine of 7 pi over 2. I wanted to show you these two problems because tangent and inverse tangent are obviously inverses of each other. You would think it would just cancel and leave you the 1. Same with arc cosine and cosine, right? They cancel. Their inverse cosine, they would cancel and leave 7 pi over 2. That works here. It does not work here. We do have to evaluate these separately. Let's find out why. Okay. Let's do arctangent. Let's do what's in parentheses first. Notice that arctangent of 1. So leaving my tangent, just doing what's in parentheses. They are asking for the angle where tangent is 1. That is at pi over 4, right? Square root of 2 over square root of 2 is 1. Pi over 4, got it memorized also. Right, that happens at pi over 4. I am in the first quadrant because the 1 is positive. So tangent of pi over 4, right? And what is tangent of pi over 4? 1, right? So you may be like, Ms. Culver, couldn't I just cancel it? In this case, yes, it works. Let's find out why it doesn't work over here. Take a look. Cosine of 7 pi over 2. Let's figure out what that is. Just going to leave my arc cosine. I'm working on the parentheses here. Cosine is 7 pi over 2. Let's rotate 7 pi over 2. That would be 1 pi over 2, 2, 3, 4, 5, 6, 7. Okay, 7 pi over 2. I'm located down here. I know what my cosine is. There it is 0. Right? We have it memorized. We know what it is on a unit circle. Okay, but if I asked you what is arc cosine of 0, you were only allowed to answer, right, in between 0 and 180 degrees, right? Or 0 and pi, right? So where is cosine? At what angle is cosine 0? Where I'm allowed to answer in the first and second quadrant, that is at pi over 2. Notice I could not just cross out the cosine and the inverse cosine to get my answer. Okay, that's because for cosine, right, we can put in any angle we want here. But for our cosine, we can only output certain angle. Let's do number 56 and we're done. Okay, on number 56, they are asking for secant of arc sine of 4/5. Oh, this looks tough. Okay. Now, they even say, find the exact value of the expression. So they want us to evaluate this. We will do inside parentheses first. Hint, sketch a right triangle. Okay, let's do that. There we go. All right, let's do inside parentheses first. So I'm going to hang on to my secant. I'm going to give myself a little bit more room. Secant. There we go. So notice that they are asking me to find the angle where sine is 4/5. Okay, I can draw a picture of that. I have the angle. Sine is opposite over hypotenuse. Right? So there's 4/5. If I asked you to tell me the trig function associated with this picture, you would tell me sine of theta is 4/5, right? Or you would say, or arc sine of 4/5 is theta, right? So there we go. And they want the secant where this is true. Okay, so let's take a look. Secant is the reciprocal of cosine, right? So I'm trying to find secant of theta, and that is the reciprocal of cosine of theta. Okay, I would need the adjacent side to do that. When I do the Pythagorean theorem, right, that would be 5 squared, the hypotenuse squared minus the leg squared. That would be 25 minus 16 leaves me not with 9, and this side must be a 3, right? And now I can say what cosine of theta is. Well, let's take a look. It is 3/5. And so secant must be 5/3. So again, my method here was to draw a picture of what I see in parentheses, and I did. To get the secant from this picture, I did need the third side, and I did call that 1 over cosine because I'm better with cosine, sine, and tangent than the reciprocal functions. And then I was able to read the triangle that cosine was 3/5 and take the reciprocal. Here we go. Have a great day.